Hello everybody. This is the fourth problem in a row. Problems on mesh analysis is being dealt in these videos. And top right corner shows my photograph and my affiliation. Now let's see as to how to do this problem. This is an interesting problem on mesh analysis. See, the problem reads, find V3 in the circuit below such that the current I1 is 0. We need to investigate or we need to look at the circuit. We need to observe the circuit carefully and understand what is to be done. Here in the circuit, V3 is unknown. It's not known to us. We are supposed to determine V3 such that I1 is 0. What value of V3 will result in I1 being 0? And we have to determine this using mesh analysis. At least that is what I have taken up in this particular video. Let's see as to how to go about this problem. And by now we have learnt as to how to write mesh equations by inspection, by looking at the network, how to write mesh equations. If you are seeing this video for the first time, I recommend you to see the remaining 3 videos wherein I have taken 3 problems, 3 elementary problems, wherein I have spoken about the method to write mesh equations and how to solve them. Alright, so moving ahead, we will write the equations now. Okay, so this is the network given. We have 3 meshes, I1, I2, I3 are the currents in those 3 meshes. So we write the mesh equations, which are 3 equations. We can write it in equation form or we can write it in vector matrix form. Let us try to write it in the vector matrix form in this particular problem as to how to write the matrices. Alright, so we will write the mesh equations. So if you, again I recommend you to see the previous videos if at all you want to know how to write the mesh equations in vector matrix form by inspection. Alright, so let's go ahead. Okay, so my impedance matrix, if I recall, it will be like this. This matrix is Z11, Z12, there are 3 meshes. It's written this way: 21, Z22, Z23, Z31, Z32, Z33. Okay, this is what we call as the impedance matrix. So impedance matrix is this, wherein Z11 is the sum of all the impedances of first loop. At Z22, another diagonal element is sum of all the impedances contained in the second loop or the mesh, and Z33 is sum of all the impedances contained in the mesh 3. So these are the diagonal elements which are unique for any network. Alright, now looking at the off diagonal elements, Z12 would mean the impedance that is common between the first and the second mesh, and Z21 is the impedance that is common between the second and the first mesh. They are always equal, they are just the same. Okay, and Z13 is similarly the impedance contained between the first and the second, and Z31 is the impedance common for the third and the first mesh, and so on. So if this format is remembered, we will try to now put the values. I will erase it eventually, but then we will try to put. Okay, so let me write the impedance matrix. My impedance matrix would be all the impedances contained in the first mesh. So I need to add the real parts, I need to add the imaginary parts. My real part would be this 5 ohm and 10 ohm, that would make it 15. And the reactance part is just J5 plus G5. Okay, that is my Z11. And Z12 is given a negative sign. What do we mean by Z12? The impedance common between the first and the second mesh. This is my first mesh, this is my second mesh, and this is my third mesh. They are carrying currents I1, I2, I3 in clockwise direction respectively. Alright. Now, we will identify what is the thing that is common between the first and the second. First and the second, if we see, this 10 ohm is something that is common. So I will take it as minus 10. Alright. So what is common between first and the third? Z13. First and the third, this J5 is common. That again has to be taken with a negative sign. Alright. Now we'll go to the second row. Okay. Second row would mean Z21 is the first element. And that is taken with a negative sign, minus of the impedance that is common between the second and the first mesh. Second and the first mesh again is this 10 ohm, that would be minus 10. Okay, Z22 would mean sum of all the impedances contained in mesh 2. That would make it 10 plus 2 is 12 minus the capacitive reactance, that is minus J4. It's preferable to put them in brackets. Okay, Z23, this element, the second row and the third element would mean what is common between the second and the third mesh. It is this 2 ohm that is common between the second and the third mesh. You have to just identify the common branch, that's all, between the second and the third, and take it with a negative sign. Take the sum of the impedances. This is minus 2. Alright, now we go to the third row. Third row is Z31. The impedance that is common between the third and the first mesh with a negative sign, minus third and the first is this J5 branch. So minus J5. What is common between the third and the second? This 2 ohm. It is taken with a negative sign. Then Z33, sum of all the impedances of the contained in mesh 3, that is you have 2 ohm and you have plus J5 minus J4. That would make it J1. So I will clear this and I will replace it with directly J1. Okay, eraser is too small. Anyway, this is J1. I'll put it in bracket. This is my impedance matrix. See, so quickly we were able to write the impedance matrix. Alright, now what do we have to write? This is the impedance matrix. So I will again, if you have a quick recap, this is Z11, this is Z11, this is Z12, Z13. This would be Z21, Z22, Z23. Then this is 3.1, this is 3.2, and this is 3.3. So we identify the impedances in this manner. Alright. So having said that, we will go ahead with the current vector. What is a current vector? So current vector is now written as, I'll take the same color. I'll write currents as I1, I2, I3. This is the current vector. Okay, I'll go back to my white. This is my current vector. This is equal to the sum of the EMFs contained in the 3 meshes, and on the right hand side we write the rises in the clockwise direction. Okay, in the first mesh, if I see, when I go in the clockwise direction, I get negative sign first, negative to positive, rise in potential. So this will be simply 50 at an angle 0. Alright, and the second mesh doesn't contain any source of EMF, so this is 0. And in the third mesh, we have a source of EMF, which is V3 at an angle 0. Alright, so we wrote the equation in vector matrix form. Alright, so this is so simple, so quick, and so easy to do, isn't it? So what is this? Mesh equations. This is nothing but mesh equations in vector matrix form is like this. Okay, shift this little below. It is sticking to one another. I will I will have to be little careful in picking this one up. I will slowly do this. Damn, man. Anyway, let me not bother too much about it. It's okay. I think it's legible enough. Okay, so having written this, now we have to find out the value of V3 such that I1 is 0. So we will write, given I1 is 0. If you want this current to be 0, what is V3? We have to determine this. Okay, this is the thing that we need to determine. Now how do we do? We can always write an equation for V3 in terms of Cramer's rule. Okay, or we can write an equation for I1 rather. I1. We will write an equation for I1. What is I1 equal to? If we remember Cramer's rule, we write I1 as equal to the ratio of two determinants. Okay, this determinant divided by what we call as the delta determinant or the discriminant of the equation. Okay, these nice equations can also be written in the form of a regular equation. Okay, something into I1 plus something into I2 plus something into I3 equal to something. That can also be written. Okay, so this is what is I1 is. I1, how is I1 obtained? I1 is obtained by replacing the first column of delta matrix. What is the delta matrix? If you remember from matrices, delta matrix is written as, I will erase this part, but anyway you can pay attention to this. Delta matrix, delta determinant is written as the components of Z11, it is 15 plus J5, this is minus 10 minus J5. Okay, and this is again minus 10, this is 12 minus J4, we have these values above. Okay, and this is minus 2, this is minus J5, this is minus 2, this is 2 plus J1. This is our delta determinant. Delta determinant is obtained by taking the coefficients of I1, I2, I3 from all the three equations and arranging them row wise. This is the discriminant. Alright. So this is the delta determinant. Okay. So I1 is obtained by replacing the first column of the delta determinant by the V vector, voltage vector. Okay. And dividing that by the discriminant delta. What I mean is, I will write what is I1 equal to. I will replace the delta, first column of the delta determinant by these values. What value? I will use the same color so that it becomes evident. This is 50 at an angle 0. This is 0. This is V3 at an angle 0. What I have done is, I have replaced the first column of this delta determinant by the V vector. Alright. So the remaining things I will write it as it is of delta. That is, this is minus 10. This is minus J5. This is 12 minus J4. This is minus 2. And this is minus 2, this is 2 plus J1. Alright. Okay. So, where this is delta. Alright. This is the value of I1. So, he says in the problem this I1 should be equal to 0. This is what is given. The value of I1 is this determinant, whatever we have written, this determinant in the numerator divided by delta determinant. The value of delta is written below. I don't want to evaluate delta because it is simple. I need not have to evaluate delta because to get I1 to be equal to 0, to make I1 to be equal to 0, I simply cross multiply this particular equation 1 and the delta will vanish. I need not evaluate delta. Alright. So, what is our I1 now should be equal to? So, from 1 I will write here where this is delta. Alright. Now, what is I1 equal to now? So, therefore, I1 equal to this value. This is 50 at an angle 0. Then I suppose 0. I have V3 minus 10, 12 minus J4 minus 2 minus J5 minus 2 plus J1. This determinant should be equal to 0. Alright, I have cross multiplied the delta. The delta is gone. So I need not have to evaluate the value of delta. It is foolish to evaluate the value of delta, which takes time. Alright, so you have to be little cautious while doing such problems. You shouldn't be very mechanical in approaching any problem. You should give it a little thought behind handling these problems. Now we will try to simplify. I suppose it's clear till here. Alright, so if it's not clear, all you have to do is you go back to the you rewind and then see, play, pause and see. That is the best part of having videos. Alright, now to determine the value of V3, all we have to do is to expand this determinant. So I will expand the determinant and write the value. Okay, so we write this as it is 50 at an angle 0. It is 50 at an angle 0. I need to be a little careful because I am prone for errors. This is 12 minus J4 multiplied with 2 plus J1 minus, you have minus 2 into minus 2. Okay, that is the first element. Now minus of minus 10. Now this is 0 into 2 plus J1. I only presume that you know how to expand it. Determinant. I presume it. Okay, 0 into 2 plus J1. Okay, so that is 0. And this becomes minus of minus. Again, it is plus. It is 2V3. This is the second element. Where should I have closed the bracket? 50 into this into this minus this into this. This is where is my bracket has to be closed. Then minus of minus 10 into this much. Then minus J5. Minus J5 into 0 into minus 2 is 0. Then I will have to put a minus V3 into 12 minus J4 should be equal to 0. What I will do is I will adjust the space little. I will take it little here, okay, so that I can be little generous in utilizing the space. This is V3 into where was I? V3 into minus J5 into this into this is C3 minus V3 into this is 12 minus J4. I will have to put 2 parentheses equal to 0. Alright. Now we will slowly expand this, carefully doing it. This comes out to be 50 at an angle 0 into, I will do the simplification. If you multiply this is 24, then minus 12 into 2 is 24 minus J12 minus this is 8J minus of minus into this is J square into 4J square. Okay, have I done it properly? This is 12 to the 24. Okay, and this is minus of minus and minus. Somewhere I have messed it up or what? This is 12 4s are 24. I need to do carefully. Okay, let me see. This comes out to be 10 into 2v3, and this is minus j5 minus, I'll take this minus also, plus j5 v3 into 12 minus j4 equal to 0. Okay. This is plus 12j. This is where was the error. Okay. Now this is equal to, what do I write? This is 58 and angle 0. This j square into 4. J square is minus 1, if you remember. J square is minus 1. You have j square equal to minus 1, because j equal to under root minus 1. J square is simply minus 1. You square this, that under root square will go. J square equal to minus 1. So this will make it, this term will be plus 4. So 24 plus 4 is 28. So I'll do that. I will do that part. Okay. This is 28. This is 28, and this is 12j and 8j. This is, I think I've done it correctly. Okay, and then I have this to be plus 20v3. All right, now I will write this as plus, what do I have? 60j 60 v3. Then this is minus j square, that again it will become plus. Okay, 5 4s are 20, again v3 equal to 0. All right. Now I may have to group the terms. If I can group the terms, I will get this to be, this equation reduces to, this is did I leave out anything? This is 24 plus 4 to 8. And I think I have missed this 4 I have missed here. There is a small error. I will correct it. What I mean is, I will remove this bracket. I will have to put this, right? This I have left out. This is minus 4 I have left out. I'll insert here minus 4 and close the bracket here. So this will be not 28, instead it is 24. 24 this plus 4 and minus 4 will go away. What I mean is, I'll pick another color. This j square into 4, that will be, and this will go away. So this will be precisely only 24. This is 24. Okay, that term was missing. Okay, I have to be a little careful in doing all these things. One has to be very careful. All right, now this comes out to be, if I can simplify, this comes out to be 1 2 0 0 at an angle 0. Okay, plus 200 into j plus, I can take v3 as common between all the three things. So v3 into, this is 20 v3 and this is 20 v3, which will make it 40 v3. v3 I have taken it out, plus j60 should be equal to 0. I'll enclose this also in the bracket. What I mean is, I'll remove this j here, I'll put j here, then put it in bracket. All right, now what is my v3? Now if I can compute v3, v3 should be equal to, it is 1 2 0 0 at an angle 0 plus j200 the entire thing has to be taken a negative sign because I am sending it to the other side, divided by the term 40 plus j60. I think I have not done any mistake here, at least now. I'll write it little properly. This is V3 equal to, this is with a negative sign. Okay, so I use a calculator and then give me a minute, I will compute this V3. This comes out to be equal to, I have to feed this minus 1200 at an angle 0 plus G of 200 within the bracket, the negative sign divided by 40 plus j60 will give me the result as minus 11.53 plus j, it is 12.3. I'll put it in parentheses, so many volts. So it's always it's preferable to keep the voltage magnitudes in polar form. So we will convert this into polar form, and this can also be written as 16.87 at an angle 133.15 volt. This is my V3. Okay, there ends the problem. Whether we have done it correctly or not, all we can do is substitute the value of V3 in, let us say, this equation. Have we named any equation anywhere? Okay, I have named it. I'll call this 2. We can call this equation 2. You substitute the value of V3 here in this equation and see if the left hand side computation results in a 0. If it results in a 0, then what we have done is perfectly fine. Alright, problem of this nature is also interesting to do. Okay, you are supposed to find the value of a source such that it results in current in any specific branch to be 0. So instead of I1, if you are expected to find out what is the value of V3 which results in I2 to be 0, how do you do? I mean, just as an extension, just a variation. Then what we do is, in this delta, we replace this column by the voltage vector. This is my voltage vector. This is our voltage vector. 58 and angle 0, 0 and V3. Okay, and then we try to do the same thing. Okay, the same computation we do, we evaluate. So I have to be a little careful, you know, one has to be careful in all these calculations. Otherwise you may end up getting incorrect answers. Okay, it's okay for people like me, but then for students who are learning, the accuracy of results are very, very important. You have to be very careful. They should not make any errors while computing. Alright, this is the 4th problem. I thought I would take it up. Each problem is of a different nature. They are slightly different from one another. The concepts are the same, but then slightly different from one another. Hope you understand this problem, and I suppose this video helps students in solving varieties of problems on mesh analysis. Thank you, and see you in the next video. Happy learning.